All right, let's get it going. This is going to be a two-day topic, today and Monday. It's actually the last topic for this unit, and we are, yes, diving back into proofs, and it's going to get a little uncomfortable here today. Even if you're top-notch proof master, it may still even get a little uncomfortable today. And then some of you that still struggle and don't want to get any help, ooh, baby, I hope for you. I do. All right. Okay, before I get into anything, though, we have to have the ability geometrically to pick out two contradictions. Now, what do I mean by the word contradiction? That means both of them cannot happen at the same time. Impossible. Both of them cannot happen at the same time. So here's what I'm going to ask you and your group, your partners, to do right now. Just start with number one. I've given you three statements. Two out of those three cannot happen at the same time in geometry. It's impossible. And that's what I want you to discuss right now. You have about 2 or 3 minutes. Go ahead. Which one of two out of those three cannot happen? It is impossible. They contradict each other. They cannot happen at the same time. Okay, so talk it over. If it's less time, great. I don't feel the need to pick numbers, or any group want to share what they think cannot happen at the same time. Pretty confident in your answer, or no? Yep. Correct. 2 and 3 cannot happen at the same time. If you remember, what is the definition of collinear? Same line. Everyone knows what a line is in here, right? And if I have an angle of 60 degrees and it's called PQR, is that a straight line right there that contains PQ and R? Absolutely not. Right? So those two cannot happen at the same time. Go ahead and number 2. Be careful. This is a little bit trickier here. Which two cannot happen at the same time? Okay, let's discuss this one. Here we go. Any group want to take a shot? What's up, man?
1 and 2.
1 and 2. So you're saying that AB congruent to BC, and hopefully you guys recognize it was those two sides and not those two. All right. These gentlemen are correct. Here's why. And then I'll take what you thought and I'll show you why it would work. Here's why. If those two sides are congruent, another group, please give me the angles that are congruent. Heaven? Angle A and angle C have to be congruent. In a triangle, congruent angles are across congruent sides. Well, here you go. Ready? Angle A and B add up to 80. Okay, go ahead. Go ahead, man. It's your problem here. So give me two angles that add to 80.
60 and 20.
Okay, so if A and B are 60 and 20, and those two are congruent, that means that has to be 20. What's the problem with my triangle? Doesn't add up to 180. You can try any possible combination that adds up to 80. If you want to get real crazy, you can go 1 and 79. And that means that's 79. Is it still going to add up to 180? No. So there's no chance that those two sides can be congruent and A and B add to 80. What were others that people thought might have been? 2 and 3? 2 and 3? Yes, no? Okay, well, here's an example of how 2 and 3 would work. A plus B equals 80. Ready? All right, so A and B could be 40 and 40. What type of triangle is it? It's isosceles. It's got two congruent angles. Right? Yeah, if you use 60 and 20 like we used here, of course it's not isosceles, but if you use 40 and 40, they add to 80 and it still makes it isosceles. All right, why am I showing you this contradiction stuff? Trying to get you guys to notice what a contradiction is, because that is how we're going to do these proofs here. It's a new type of proofs today. All right, we're still going to go statements, reasons. You will just know a glaring difference, I hope. I'm not going to read this all to you. We're going to jump right into it. We're starting with proof number 2 on the next page, by the way. Proof number 2. One's a little bit too tough to start out with. Start with proof number 2. Please just look at the given in the proof statement. Somebody let me know what's brand new to us here that we've never seen in the probably 100 plus proofs we've done already this year. There's some glaring differences that we have never ever seen. Max, one thing. I didn't think about that, but we haven't seen altitude yet. But do we know what an altitude does now? Okay, so we can now use it in a proof. He's correct. I didn't even think of that. More that's glaringly obvious here. Rachel? Have I ever asked you to prove something's not happening? Okay, here we go. This is the first time. So we notice that we're trying to prove something is not happening. That tells me this is going to be an indirect proof, also known as proof by contradiction. And also, while we're on the topic here, anybody see something different in the givens I've never given you before? Nick? Something's not happening in the givens. Okay, I've never seen that before. All right, this one's going to be uncomfortable. Just grind through it here. All right, and I'll try to tie it all up in a nice bow at the end. All right, but just grind through it. Givens are already in. We're going to start this proof out differently than we have in the past. Yes, we put the givens there, but also now our second step is, everyone see the proof statement. We're going to assume the opposite is true. All right, so instead of BD does not bisect AC, I'm going to say, you know what? I'm going to assume BD, what would be the opposite? Bisects AC. And that is what I'm calling my assumption. So that's how I'm going to start an indirect proof out, is saying the opposite of what I'm trying to prove is true. Watch what happens now. Nick, what was so strange to you again? That was a little strange, right? Can you guys please help me now prove it is isosceles? Watch this. Ready? Prove that this triangle is isosceles for me. What do you know about an isosceles triangle? Two congruent. Can we get two congruent sides or two congruent angles? We can if we prove the... Now we're going back to old stuff now. Old stuff. If I need sides or angles congruent, probably a good idea to prove the what congruent first? The triangles. So help me right now get those two triangles congruent. That's our job right now. All right, and I'll take over at the end. Try to get those two triangles congruent to each other. And, you can use your assumption now as a given. It's in your proof now. It's true. We're assuming that's true. So now we can use that as a given. So what I need from people right now is either sides or angles that'll help me prove those two triangles congruent. All right, start us off here. Here we go, 5, start us off. Anything I can use up here?
Line BD, or angle BDC.
Okay, how do you know that, Mike? And meaning on the other side, it's a right angle too, right? Okay, perfect, nice. So angle BDC and angle BDA are right angles. Guys, usually our reason would be perpendicular lines form right angles, right? Well, how did Mike, how'd you know it was right angles there? Definition of an altitude. This isn't going to change, though. When you say they're right angles, we probably should say that they are congruent. All right, that's not going to change. This is why I said at the beginning, if you struggled with the proofs before and didn't get any help, this part's not getting any easier. That's coming back. What was the reason for the right angles being congruent? All right angles are congruent. Okay, so you got right angles. What else? Still looking for another pair. Maggie, go. We can still use it. Absolutely. BD congruent to itself. You guys are on a good pace right now. Okay, I got a pair of angles. I got a pair of sides. Max. Again, if you didn't hear me the first time, your assumption can be used as a given. Use your assumption. So AD is congruent to DC. How'd Max know that? Because BD is bisecting AC, so that's definition of a bisector. Are the triangles congruent now? What method? Side angle side. All right, where are we going with all this? You'll see in a second. So triangle BAD is congruent to triangle CA. If I go BAD, I got to go BCD. Okay, triangles are congruent. Give me a pair of angles or sides now that are congruent. Remember what I asked you guys to do? Show me this bad boy's isosceles, and you almost have, right? You're almost there. You can go angle A congruent to angle C, or I could go AB congruent to BC. Which one do we want? The angles or the sides? Sides? Okay. Go angles. Go ahead. So I got to keep going up and down here. BA and BC are congruent. And I know some of you are still wondering where I'm going with this. Hold on tight. I don't want to write the reason. Emma? Let it roll off the tongue, everyone, in the correct order. CP, CTC, yeah. What do I know about triangle ABC now? It is. If BA and BC are congruent, that triangle is isosceles, yes. Why is it isosceles? Because you have two congruent sides in a triangle, yep. Implies it's isosceles. And then I want you to just put down your pencil and look at your proof right now, or pen, whatever. Something is very wrong in your proof right now. Very wrong. Nothing what we wrote down. There's something impossible happening in everybody's proof right now, including mine. Remember we talked about contradictions before? There is a huge contradiction in everyone's proof right now. Guys, what did you say? What did we say in the givens? ABC is, and then all of a sudden down here in step 9, you're telling me, I don't think that can happen. That it is and it isn't. Everyone agree? Okay, let me go slow and try to wrap this proof up. What led us to that triangle being isosceles? Our darn assumption, right? We said this is true. We assumed it was true, and what did it lead to? A contradiction, that it was isosceles. So what can you say about my assumption? It's got to be false. It's wrong, isn't it? Because it led to a contradiction. So ready? If my assumption, this statement right here, is false, it's untrue, tell me a true statement then. If BD bisects AC is false, Amy, what's true? Which is our proof statement. Okay? Because our assumption led us to a contradiction, the assumption is false, meaning the opposite, I can't go up there, but the opposite is true. So once you have established a contradiction in your proof, you now know the opposite of your assumption, which is your proof statement. BD does not bisect AC is a true statement. BD does not bisect AC. And here's where we're going to end every indirect proof. Why is that true? Because our assumption led to a what? Contradiction. And I never know, is it I or A here? A? And to help you out and to help me out when I correct these proofs, in parentheses, I'd like you to tell me what steps in your proof represent the contradiction. So in our proof, what steps represent the contradiction? Step. Well, the contradiction. Where did we get the contradiction? It was the isosceles one, right? So step 1, which was ABC is not isosceles, and step 9, which saying it was isosceles. Okay? So that shows me where your contradiction is. Oh, we're going to go back up to 1. Go ahead, Amy. Yes. Because here's what, and this is what I'm just going to talk about before we go to this next proof. You always make an assumption that'll lead to contradicting one of your givens. That's the way all these work. Okay? You make an assumption, which is always the opposite of the proof statement, and you try to contradict one of the givens. Okay? Which given is it always easiest to contradict? The not one. Okay? The not one. Always easy to contradict the not given. All right, here we go. Next up, go right up above to 1. You guys are going to have a lot more input now on it. First question, before we write down anything. How do I know to do this indirectly? I know it's indirect day, but what happens, let's say, 5 weeks from now when we're in the midterm, and you get one that looks like this, and you're like, oh, I got to do this thing indirectly. Proof by contradiction. What up here is saying to do it indirectly? Let's do this. Here we go. 4. Where? Prove. That's where I'm looking. If the proof statement is telling me to prove something's not happening, it's indirect. Givens are already here. Next step should be my assumption. I don't want you to make this mistake. Where does your assumption come from? It's the proof statement, guys. It is never from the givens. It is the opposite of the proof statement. So what is your assumption in this proof? Here we go. 2, what's your assumption? Yes, please. I can't stress that enough. The assumption is from the proof statement, not the givens. What are you trying to contradict? A given. So everyone, take a look right now at the 2 givens I have up there. Which one do we want to try to contradict? Amy, which one? Yeah, try to contradict the one that's not happening. So how do you contradict it then? By saying that they are equal. So here's our goal right now. Get BD, side BD, and side BE congruent to each other. Cameron, go. Yep.
Are we having both of them? Like, are we writing both of the opposites, so the proof and the given?
No. Your assumption is the opposite of the proof statement. We're assuming the opposite of the proof statement. No, what I'm saying, now our goal is take one of the 2 givens I've provided and contradict one of them. And I'm just saying it's easier to contradict these. And I asked everyone, how would you contradict BD not being equal to BE? By saying they are equal. So this is not a given at all. I'm just saying this is our goal right now. You guys got to get me here. Because when you get me there, then you'll contradict that given. No. I don't want you to contradict because once you contradict the proofs, we're done with the problem. You see what I'm saying? You sure? So here's our goal right now. I need everyone to get BD equal to BE somehow. Somehow. Again, I'll say this before. What have we done in the past to get sides congruent? Prove the triangles congruent. So you guys right now in your groups, find me a pair of triangles that contain BD and BE as full sides. Make sure BD and BE are full sides in the triangles you pick to prove congruent. Okay, did we pick a triangle? Did we pick a pair of triangles? Here we go. 13. What's our triangles? C, B, D. All right, everyone ready? Those contain full sides, BD and BE. Let's go to the givens. AB is congruent to BC. That gives us a full pair of sides, right? And again, I'm going to keep sounding like a broken record today and Monday when we do this for a second time. Your assumption can be used as a given. So we can mark on our diagram that A is congruent to C because we're assuming that's true. Guy, I had given you 2 pair right now. You are on the hook for the 3rd. Will, where's it coming from? Anytime they overlap, look for a reflexive angle, right? So angle B congruent to itself. Reflexive. Now you guys just got to figure out why they're congruent by what method here. Don't yell anything out. I'll ask somebody. Remember we had 5 methods. Triangle ABE is congruent to triangle CBD. Why? What method do you have for me here? Here we go, 18. Angle, is that side in between everyone? Yes, it is. And if you're unsure, what did we say in the previous unit? Draw it out separately and mark it. Yep. All right, the triangles are congruent, which means what sides now are congruent that we wanted? BD is now equal to BE. Reason? CPCTC. And what do you have now in your proof? You contradicted the given, didn't you? Which would mean what about our assumption? It's not true. It's false. So if A congruent to C is false, that must mean A is not congruent to C. Our assumption led to a contradiction. So is everyone seeing the goals in these proofs? Yep. Yep, correct. So for us, it was what? 1 and 5. Anything else? All right, I am going to still work on the next proof with you, even though it's for homework. So let's get going with it. So we're starting from scratch here. Everyone see, proving it not equal. So I'm like in proof by contradiction indirectly. And you guys can put the givens and the assumption in any order you want, right? Can be at the beginning, can be the second step, whatever floats your boat. Something slightly different here. What are you guys having as your assumption for this? What are you assuming is true? 4, what are we assuming is true? Yep. And just remember, guys, you can use that now in the proof. All right. There is one little switch here. Remember, we want to try to contradict a given, right? And what I've been telling you guys the last 2 proofs is, oh, just contradict the not equal one. Do we have one of those, though? Ah, darn it. But that doesn't mean we give up. We're still going to have to make a decision. Out of those 2, which one do you think right now? Think about it. Which one, out of those 2 givens, which one do you think it's going to be easier to contradict? Because we still got to contradict one of them, regardless if it has a not equal or it doesn't. Which one do you think is going to be easier to contradict? ABC scalene or those 2 are altitudes? What's up, Mike? Well, how would you contradict it? Namely A? Everyone agree? If you can show me ABC's isosceles, doesn't that contradict its scalene? Okay, Mike found out what we're got to do here. Good man. Triangle ABC's isosceles. So let's prove it isosceles. And again, the only way we're going to do that, two sides or two angles, right? What do you want to go with? Two sides or two angles? Well, we better find out what we have first here. I got AE and CD are congruent. I don't know. That's a tough one to mark on here, but AE and CD are congruent. And what about those altitudes? What are they doing? Okay, name an angle that's going to be a right angle. BDC, okay? And also the one next to it, right? And where do I have another right angle? If AE is an altitude. AED, AEB, and AEC, all right. Do you think it's going to be easier to prove angles or sides in that triangle based on all this information we have now? Angles, in which two triangles? Name the two triangles we can prove a full pair of angles in. ADC and I haven't highlighted that one yet. That's going to be the second one. And AEC. Because take a look. You prove those triangles congruent, which we already have some info about. Those whole angles will be congruent and it'll be isosceles. Is everyone good on the plan? Because it's going to get a little shaky from here. Oh, it's going to get shaky. All right, so I already have what? I got the assumption, so I got a pair of sides. I still need to mention the angles that they're right. So angle CDA and angle AEC are right angles. Why, guys? I know you guys are so used to perpendicular lines form right angles, but there we go. I don't know, and if you want to write that they're congruent, go ahead. I'm going to hold off because I know what's coming ahead of us. Do you guys see any other sides or angles right now that you can write down? Maggie, what's up? Boom. So you guys think we have three pair and we're good to go. Hate to break, ready? There's the side we have. Look at that blue triangle I have up here. I got the side, this side, and that right angle. Is that right angle in between them? Is that right angle in between these sides right here? Oh, so there goes side angle side. Don't even speak of side angle. Don't even speak of it. So that's out of the question. Hello, Heaven. Yeah, but here's the problem. My yellow triangle, that's not a full angle, though. You see why? It's a full angle in the DAC is a full angle in my blue triangle, but it's not a full angle in my yellow one. Okay? Hello, Sean. Whoa, how about that one? Breaking that out of the old closet, huh? HL, he says. Well, let me check. HL can only be used on what type of triangles? Do I have that? Okay, so the H and HL is for, H is for? Okay, that's AC in both cases. And what's the L? And that's AE and CD. So it looks like, yes, you were correct, young man. You can use hypotenuse leg. But, Amy, guys are good. Got to say the right triangles first. Triangle CDA and triangle AEC. Yep. What are you talking about? What do you mean? The triangles are congruent, Cameron? You could say it. Go ahead. But in HL, I don't need the right angles to be congruent. In like side angle side, I would. Angle side. Okay, but HL, I don't need it. Is it wrong if you do it? No. Anybody remember why these are right triangles? Oh, right triangles have right angles. Now I can say they're congruent by HL. Whew, this one is nasty. Whew, love it. Triangle CDA congruent to CDA AEC. All right, why did we need those darn things congruent anyway at the beginning? We want to say it's isosceles by saying it's got, and what do we have now in this case? We don't have the sides, unfortunately, but we do have, what are those two congruent angles that I need? Don't call it angle A and C, because I'm going to be more specific on your paper. ECA is one of them, yep. So angle ECA congruent to DAC, and that reason's going to be? Mike, you're on fire today, huh? He's just going to walk out and we'll be like, what just happened? And forget everything. He's just in this zone right now, the blackout zone. What do you now know? Come on, let's go, champ. It is. ABC's isosceles. Because it's got two congruent angles in a triangle imply isosceles. What do you guys have on your paper after you write step 8? Contradiction, because you told me at the beginning it was scalene, and then all of a sudden it's isosceles. I don't think that's true. So what do you know about your assumption then? My assumption was false, so I know now that AE cannot be congruent to CD because my assumption led to a contradiction. And you guys can get, oh, hold on, what lines? I know ours may be different depending on where you put your given and your assumption, but for me, I kept my givens in step 1, and that contradiction ended up being step 8. Yes. And it's helpful for you too. Like, you know you have a contradiction when you write it down. Okay, you guys go ahead, get started on the next one. All right, get started on the next one. See what you can do.